National Electrical Code Article 310.15.B.2.b addresses the spacing requirements for conduits, tubing, and raceways when multiple runs are installed together. The core intent of this requirement is to ensure adequate heat dissipation from conductors and to provide sufficient physical space for maintenance and future modifications. When multiple conduits or raceways are bundled together without proper spacing, the heat generated by the conductors within each conduit can accumulate. This phenomenon, known as mutual heating, reduces the ampacity of the conductors. Ampacity refers to the maximum current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The accumulation of heat degrades the insulation of the conductors over time, leading to premature failure, electrical faults, and potential fire hazards. By mandating spacing between conduits, the code promotes better air circulation around each conduit or raceway, which facilitates heat dissipation. This improved cooling helps maintain the conductors within their safe operating temperature range, thereby preserving their insulation integrity and extending their service life. The spacing requirements also enhance accessibility for maintenance and repairs. When conduits are tightly packed together, it becomes difficult to access individual conduits for inspection, testing, or replacement. Maintaining spacing allows electricians to more easily identify, isolate, and work on specific conduits without disturbing adjacent runs. This accessibility reduces downtime, simplifies troubleshooting, and minimizes the risk of damage to nearby conductors and equipment. Furthermore, proper spacing facilitates future expansion or modification of the electrical system. If additional circuits or conduits need to be added, the existing spacing provides room to maneuver and install new infrastructure without causing undue stress or interference with existing installations. This foresight ensures that the electrical system can adapt to changing needs over time without requiring extensive and costly rework. From a practical standpoint, achieving the required spacing can be accomplished through various methods. Firstly, conduit spacers, which are non-metallic devices designed to maintain a consistent gap between conduits, can be used. These spacers are typically installed at regular intervals along the conduit run, ensuring uniform spacing throughout the installation. Secondly, cable trays or ladder racks can be employed to support and separate multiple conduit runs. These systems provide a structured framework for routing and organizing conduits, while also providing ample space for ventilation and accessibility. Thirdly, when direct burial of conduits is necessary, maintaining spacing can be achieved by carefully excavating trenches and positioning the conduits with appropriate separation. The backfill material should be compacted evenly to provide stable support and prevent shifting of the conduits over time. Now let's examine the specific requirements outlined in the National Electrical Code. While the code mandates spacing, it does not specify a precise minimum distance. Instead, it requires that spacing be maintained, leaving the interpretation to the authority having jurisdiction or the qualified electrician. This flexibility allows for consideration of various factors, such as the size and number of conductors within each conduit, the ambient temperature, and the presence of other heat-generating equipment. In general, a spacing of at least one conduit diameter is considered adequate for most applications. However, in situations where conductors are heavily loaded or ambient temperatures are high, greater spacing may be necessary. It is crucial to consult with a qualified electrical engineer or inspector to determine the appropriate spacing for specific installations. Failing to comply with the spacing requirements of National Electrical Code Article 310.15.B.2.b can have significant consequences. Overheating of conductors can lead to insulation breakdown, which can result in short circuits, ground faults, and arc flashes. These electrical faults pose serious risks of fire, electric shock, and equipment damage. Additionally, non-compliance can result in code violations, fines, and potential legal liabilities. Electrical inspectors have the authority to reject installations that do not meet the code requirements, requiring costly rework to bring the system into compliance. Therefore, it is essential for electricians and electrical contractors to be thoroughly familiar with the spacing requirements and to implement best practices to ensure compliance. This includes careful planning, proper selection of materials, and meticulous installation techniques. Regular inspections and maintenance should also be conducted to identify and address any potential issues before they escalate into serious problems. To further clarify the application of National Electrical Code Article 310.15.B.2.b, consider some practical examples. Firstly, imagine an industrial facility where multiple 480-volt feeders are routed in parallel conduits to supply power to various pieces of equipment. Each conduit contains 3 500 kc mil copper conductors carrying a substantial amount of current. If the conduits are bundled tightly together without spacing, the heat generated by the conductors will accumulate, causing the insulation to overheat and degrade. This can lead to premature failure of the conductors, resulting in costly downtime and potential safety hazards. By maintaining adequate spacing between the conduits, the heat can dissipate more effectively, keeping the conductors within their safe operating temperature range. Secondly, consider a commercial building where numerous low-voltage control cables are routed in conduits along a wall. While the current in these control cables may be relatively low, the sheer number of conduits can still create a significant heat buildup if they are not properly spaced. This heat can affect the performance and reliability of the control systems, leading to malfunctions and disruptions. Providing spacing between the conduits allows for better ventilation, preventing excessive heat buildup, and ensuring the proper functioning of the control systems. Thirdly, envision an underground installation where multiple conduits are buried in close proximity to each other. The soil surrounding the conduits acts as an insulator, trapping heat and exacerbating the effects of mutual heating. In this scenario, it is particularly important to maintain adequate spacing between the conduits to promote heat dissipation into the surrounding soil. The depth of burial also plays a role in heat dissipation, with shallower depths generally providing better cooling. Now, let's discuss some of the factors that can influence the required spacing between conduits. Firstly, the size and type of conductors within each conduit are critical considerations. Larger conductors generate more heat and therefore require greater spacing. Similarly, conductors with higher temperature ratings can tolerate more heat buildup, potentially reducing the need for extensive spacing. Secondly, the ambient temperature of the environment in which the conduits are installed is a significant factor. In hot climates, greater spacing is necessary to compensate for the increased heat load. Conversely, in cooler climates, less spacing may be acceptable. Thirdly, the grouping of conductors within each conduit can also affect the required spacing. When multiple conductors are bundled tightly together within a conduit, they generate more heat than if they were spaced apart. Therefore, it is important to consider the fill ratio of each conduit and to adjust the spacing accordingly. Fourthly, the presence of other heat-generating equipment in the vicinity of the conduits can influence the required spacing. If the conduits are located near transformers, motors, or other sources of heat, additional spacing may be necessary to prevent excessive heat buildup. Finally, the type of conduit material can also play a role in heat dissipation. Metal conduits tend to dissipate heat more effectively than non-metallic conduits, potentially reducing the need for extensive spacing. However, metal conduits can also be more susceptible to corrosion, so it is important to select the appropriate material for the specific environment. In addition to the spacing requirements outlined in National Electrical Code Article 310.15.B.2.b, there are other related code articles that address conductor ampacity and insulation practices. National Electrical Code Article 310.15 provides general guidelines for determining conductor ampacity, taking into account factors such as conductor size, insulation type, and ambient temperature. National Electrical Code Article 300 covers general wiring methods and materials, including requirements for conduit installation and support. National Electrical Code Article 314 addresses outlet boxes, junction boxes, and pull boxes, including requirements for box fill and conductor bending radius. By understanding and complying with these related code articles, electricians can ensure that electrical installations are safe, reliable, and code compliant. The intent of National Electrical Code Article 310.15.B.2 B extends beyond simply preventing overheating of conductors. It also promotes energy efficiency and reduces the overall carbon footprint of electrical systems. When conductors are properly cooled, they operate more efficiently, reducing energy losses and minimizing the demand on the electrical grid. This can translate into lower energy bills for consumers and reduced greenhouse gas emissions for power plants. Furthermore, by extending the service life of conductors, proper spacing reduces the need for frequent replacements, minimizing waste and conserving resources. In conclusion, National Electrical Code Article 310.15.B.2.b serves a critical role in ensuring the safety, reliability, and efficiency of electrical systems. By mandating spacing between conduits, tubing, and raceways, the code promotes adequate heat dissipation, enhances accessibility for maintenance, and facilitates future expansion. Compliance with these requirements is essential for preventing electrical faults, protecting property and lives, and promoting sustainable energy practices. Electricians and electrical contractors should be thoroughly familiar with the spacing requirements and should implement best practices to ensure code compliance.